Okay.
Yeah, we're live.
Oh, okay. Sorry, working through backwards. Okay. So our project was about how do we ensure that individuals select the best healthcare insurance plan that's tailored to their individual needs. So, why TLDR? Well, basically, TLDR just means that you have a long or complicated thing, usually like words, but you just simplify it, and that's the point of the our app. So basically, choosing the right health insurance plan isn't just about like the lowest premium; it's about like a variety of issues. That's why we noticed that traditionally insurance selection relies on static comparison tools, basically spreadsheets, and that aren't really tailored for like an individual's medical needs. So we wanted to leverage AI in order to create a data-driven and personalized recommendation system, and that was our underlying philosophy. So choosing an insurance plan is pretty complex, as you'll see in a second. This is what you'll probably see right now if you go to the New York State insurance recommendations, and with TLDR, this is the final product. And we can start our demo now. So I'll stop sharing and then let Kelvin share his screen.
You guys can see it, right?
Not yet.
Oh no, that's weird. Why is it not
So
showing?
Kelvin's going to do a live demonstration. If anyone has any questions, they can ask at the end. You'll see we have a feature for that.
Is it working?
No, do you want me to do it?
Is it working?
Oh, now it's working. Yes.
Okay. Okay, cool.
So Kelvin's entering his name, gender, age. All these factors are really important, as we'll discuss later when we talk about the backend, the ML server of the app. But you'll see later. So Kelvin puts in his height, his weight, puts in his income. Let's put in yeah. And then this is very important. Health conditions. He's gonna fill out this form. And then it will instantly generate the best plan with very simple to understand numbers: the premium, deductible, max out of pocket costs. So, Kelvin, go ahead. If you have any questions about your plan, go ahead and ask Cindy, the chatbot. So, what is a premium, Kelvin?
So a premium is
Okay, that's good. So, I think that's a good demo. Do you want to ask it any more questions? If anyone has any questions in the chat, they can ask any questions. Okay, looks good. Okay, so we can talk about um, the AI that went into this, and especially the data collection process and how we actually use the data to build this model.
here. Let me stop sharing my screen then.
Yes, I'm gonna share my screen. Give me a second. So the truth is that building AI models can be quite boring. Yeah, it sounds really cool on paper, but reports have shown that data scientists spend around 80% of their time just preparing data. But this really just shows how important having data that is easily processable by algorithms is. And this was no different for our project. So initially, we spent a lot of time looking for data sets. The actual data sets that we would use, um, it's very important. So basically, we found around 10 data sets, and we pre-processed each of them, and this resulted in one comprehensive data set. I think there's echo. Okay, but this resulted in one comprehensive data set that included insurance plans in New York State. Features included company plan metal level, so either bronze, silver, or gold, as you guys already saw, financial costs, specialist out of network coverage rates, plan denial rates, and very importantly, also featured plan appeal rates and plan appeal rate success rate, or if it failed, and also gave the reason for why it failed. For some people, this is really important, especially if they have trust issues with their insurance company. All these are really important factors that a static recommendation model cannot provide. What's really cool is we actually were able to find a second data set that we were able to use to predict a customer's expected annual medical expenditure based on factors that you guys saw earlier, such as age, BMI, and chronic health conditions. This allowed us to train a prediction model that allowed us to estimate an individual's average yearly medical spending, and then use this model, use this information to further assist our app to find the best insurance plan for the user. So let's talk about modeling. This is what you guys are here for. So in order to create our additional model, being able to calculate annual medical expenditures is incredibly important. So we had 3 initial models that we decided to use for training. Obviously, we got to start with the simple linear regression. And then we decided to use decision trees, but not just any decision trees. We wanted to use a cap boosted gradient boosted decision tree. And then finally, we used a deep learning technique, which is obviously the feed forward neural network. You guys see it here. The cap boost model, surprisingly, actually outperformed the feed forward neural network. I think the linear regression, we would expect it, especially considering how much variables there are within the data set, to not have the best performance, right? But the cap boost gradient boosted decision tree, sorry, it's a mouthful, actually outperformed the neural network with the highest R2 score and the lowest RSC. So now we're going to actually show you a visualization. So this is just the overall view of how our model works, or our app actually. So as you guys saw, the user query goes in here, goes into the front end, and then here is the ML server, which I'm about to go into detail on. But this is the ML server. We have 2 data sets, the medical cost data set and the insurance companies and plan data set. One goes through a CAPUS classifier, which basically estimates annual medical costs, and the other one goes through a classifier, and all this ends up back in the back end, which then it gets sent to Google Cloud Run, which is how you guys are seeing the deployment that you guys just saw. So I am very interested in talking about the ML portion. So this is basically a simplified logic flow chart of how all the information you guys just saw us enter, how it goes into our models. So we start with the initial user query, and we take the gender, age, height, weight, smoker, and whether or not you have chronic conditions. So the height and weight actually go into BMI calculation, which is a very important feature weight within actually calculating medical expenditure. So from here, we have an insurance medical cost data set, and using, like we said, the CAPUS classifier, we were able to estimate a customer's annual medical expenditure, basically how much you're estimated to spend this year. And that plays a huge part in calculating your, let's say, how much you want to pay max out of pocket, because you will be willing to pay a little more monthly, if it means your max out of pocket a year is much lower, if you know you're going to have high medical costs. From here, we have our medical plans data set, basically the data set that I discussed before of companies, plans, denial rates, appeal rates, all that. So basically that allowed us to create a weighted insurance plans ranking. And if you see here, here you guys saw the annual income and the specialist preference, and it goes into this weighted insurance plans ranking, which after these 2 models go through, gets sent as one recommended user insurance plan, which you guys saw at the end. And from here, we trained a large language model using Grok, and basically it's connected to the insurance plan, so it knows which plan is recommended to you, as well as information about each individual medical plan within the data set. And then this gets sent all to the web app. Okay, so from here, I think Kelvin's going to talk about the AI chatbot, which we trained using Grok.
Yeah. So basically, the chatbot, currently our system relies on structured data such as like premiums, denial rates, and user demographics. However, user reviews and feedback on insurance companies, which are found on forums like Reddit, contain valuable qualitative insights. So we should, like, we wanted to like create a product. Sorry, let me gather my thoughts. So basically, we wanted to create a recommendation system with a chatbot. So we trained a chatbot on the already like processed data sets that we used. And then based on that, we incorporated Grok's LLM into our chatbot service.
Do you want to take this, Kevin, or I can take it?
Yeah. So basically, as I said before, sorry, I was like a little bit messy. Currently, our system relies on structured data such as premiums, denial rates, and user demographics. However, user reviews and feedback on insurance companies found on forums like Reddit contain valuable qualitative insights. We could incorporate deep learning based natural language processing to analyze these reviews to extract sentiment and feedback about specific plans or insurers, and train our AI chatbot on this data as well. So in conclusion, AI-driven insurance recommendation can improve healthcare affordability and accessibility. And by using machine learning and our chatbot, we can help individuals make better informed choices tailored to their medical needs.
Okay, so now is a good time for questions. Our presentation is done. If you guys want to see another demo, we can go through another demo.
Awesome. So thank you so much, guys. This is amazing. I personally really enjoyed it. As you know, we kind of talked earlier today, and I'll look forward to kind of chatting to you soon. And unfortunately, we're out of time, but great job, guys.
Okay, thank you so much for having us.
Thanks for having us.
Yeah.
Hi there. Can you hear me?
Yeah, I can hear you okay.
Nice to meet you.
Is Maggie also on your team?
No, just me.
Okay, cool. So it's nice to meet you, Michael. I guess we
Nice to
can
meet you too.
kind of get started. Yeah.
All right. We'll get started. Let's see. All right. Can you see my screen? Everything good? Okay.
Yeah, all's good.
All right. Thank you. All right. So it'll just be me today. I had two other teammates, but here's our project. We created this for Columbia's DevFest hackathon over the weekend, and we created an AI-powered mock interviewer, and our project name is called Mocker. Here are my two other teammates. I'm currently a freshman attending college, majoring in computer science, and my two other teammates, which are not here, are also in the same college as me, and they're juniors. So here's a little bit about our project. Mocker aims to be an AI-powered mock interviewer for technical interviews for software engineering. And why I wanted to create this product was because when I was trying to practice for coding interviews or try to do mock interviews or actual interviews with other companies, I found that I was stumbling on my words and trying to relay my thoughts was very difficult. So what was the solution that I came up with? OpenAI recently released their beta version of their real-time API, as well as LiveKit's agentic multimodal agentic functions. And here I thought to myself, how can we create an AI that allows you to practice these mock interviews in a more realistic way? So after some thought process and ideation, we created a product that where you're able to write and run code, think and speak your thoughts to an AI, and the AI can also give you realistic feedback, such as questions or hints to what you're doing, and more. Here's some statistics on why I chose to do this type of project. Here we can see a little bit about the performance of interviewers consistently, as well as on-site FANG interviews. And especially during a pressured environment where you have to communicate your thoughts as well as write code, it is very hard to be able to consistently do this. So by being able to have this AI-powered mock interviewing session, you can have more time and more opportunities to, I guess, practice this type of skill. So what are some of the features that we used here? So first, the text to speech and the speech to speech is the most important. It's the MVP of the product, right? We also have a built-in IDE using Microsoft's Monaco editor, where you're actually able to switch between different coding languages of your choice, and you're able to write code and run code. 3 is the test case, where you're able to run code in a safe environment where data is not leaked. So your personal information or whatever functions that you're calling onto our server is safe and there's no data breaching. What are some of the actual products that we use in order to create this? As stated before, we used OpenAI's real-time API, And here we use that in collaboration with LiveKit's multimodal agent. So we're able to make it have callable functions, such as whether or not they want to ask you a question, or whether or not they want to test what you're thinking, or whether your thinking is right, or maybe think of something in a different way in order to test you. You can set the functions and set the way that you want the AI to ask you these questions in a different way. And also we have modal and Monaco editor in order to write code and run code in a safe environment. And we can do a little bit of a demo, although the MVP or prototype of the product is a little bit buggy. You'll be able to see a couple of, let me switch the screen sharing. Here's like a prototype of our product that we made over the weekend. Here you'll be able to select a couple of different options of the topic that you want to do, and also the difficulty. And when you load onto the webpage, you'll be able to see that a question has been created using Grok, as well as the constraints and example cases, as well as test cases that you're going to be playing against. So if we were to go to the question and write something random, such as some type of function like this, and has a return statement, be able to run tests, and test cases or test results will be able to show whether or not you actually passed or failed in this case, which in this case is failed. And also there's a button here to start your conversation with the AI. And we won't go through with the production of that because for time's sake. But yeah, and let me switch it back to the presentation. All right, and that is it for our product. And thank you.
Wow, incredible, Michael. Thanks.
Thank you. I
So much
appreciate it.
for your time. And
Thank you.
fortunately, we're out of time. I would ask a few questions, but great presentation.
And thank you. Appreciate it. Have a good one.
Awesome. So next up, we have the NutriVoice team, right? So Hinkang, Maggie,
Yeah.
and Be Wrong, right?
Yeah.
Anyone else from your team?
There's one more person joining.
What's their name? They're probably in the waiting room. Yeah.
Sadia.
Oh yeah, Sadia. Cool. Awesome. So Team NutriVoice, we met at the Columbia DevFest Hackathon as well. Built an amazing product, and we'll let them take it away from here.
First, we want to start with some self-introductions, and then we'll move on to present our project. King Kwang can start first.
Yeah. Hi everyone. My name is King Kwan. Yeah. And so my role is basically product manager. I do the product management and do the architecture design. So I decide like what kind of tools, what kind of technology, what kind of like language we use, something like that. And then when we do the coding part, like my job is kind of push the team and then how each teammate to work together. Yeah. Thank you.
Hello everyone, my name is Maggie. My goal for this depos was mainly user researcher. I used Lucidchart to build up the database schema and the concept map and the statistical data for the model. I also advised on some CSS features and assisted with prompt engineering, which is very important whenever you're using AI models. And we implemented OpenAI and Growth Vision API. Now I'll move it to Sadia.
Hello, everyone. My name is Sadia. I worked as a front-end developer at NutriVoice, and I used React.js and JavaScript.
Now that we ended up with the introductions, I would like to share the screen and give. Okay, now it's the Birong's turn. I forgot.
So my name is Biran. I'm mainly contribute to the full stack of the project, basically focusing on front end, making it responsible, and then the full, and then back end will be like using Flask to integrate Grok and OpenAI's API into the projects. That's basically it. Thank you.
Okay, great. Now that we finished, it's time to share the screen and give you guys some overview. Okay, so this is NutriVoice. What is NutriVoice? Basically, the mission behind it is to provide personalized, accessible, and voice-assisted nutritional advice to blind and visually impaired individuals. Why does it matter? Many nutrition resources rely on visual elements, excluding a significant population that could benefit from tailored health insights. Therefore, our target group is blind and visually impaired individuals who need assistance with nutrition planning. We've noticed that visually impaired individuals struggle with reading food labels, tracking their diet and calories, accessing structured nutritional guidance, and also using conventional nutrition apps that rely on visual data. The key statistics that we noticed during our research is that 285 million around the world have visual impairments. Out of these, 39 people are completely blind. 70% of those blind individuals struggle with access nutrition information due to lack of accessible resources, 35 of which have higher risk of diabetes due to difficulty tracking their food intake. 67% of blind people rely on voice-assisted technology, but find most apps inaccessible for food tracking. As we noticed, those numbers are relatively high, and the target group is relatively large. Therefore, the need to create an app that would give nutrition planning to these people who have visual impairments would be necessary. The competitor analysis, we noticed that applications such as MyFitnessPal are popular for nutrition tracking. However, they're not accessible for blind users. Yuka also scans barcodes for food insights but lacks voice control. Seeing AI, which is by Microsoft, assists blind users but doesn't focus on nutrition. How does NutriVoice stand out? It's a fully voice-controlled experience and AI-driven personalized nutrition recommendation. This app is voice guided for all the meal planning. The tech stack overview. For frontend, we used React.js. For backend, we use Python and Flask. For AI tools, we use speech-to-text recognition using Whisper API on Grok, image analysis using Vision API with Grok and OpenAI Vision API, and for feedback, we use our LLMs on Grok. For database, we use MongoDB. The database schema shows the table of the user, which is connected with the nutrition plan, the calorie intake, and the food. And all of these together make it possible to communicate with the APIs and store data while we're giving recommendations. The levels of accuracy. After testing the model several times, we noticed that the food recognition accuracy was almost 92% for identifying food and items using OpenAI Vision API, and also the calorie estimation accuracy was 88%. The highest level of accuracy was for speech-to-text recognition, which we're very proud for. Now, I would like to move it to the demo. So I'll stop share my screen and leave it to King Kwan.
Yes, great. Okay, sounds great. So let me share the demo. So it seems you cannot hear it. So let me check. How about right now? When a blind person opens our app, they provide personal details. Like I can do it right now.
Recording selected.
My name is Jake. I'm male. My current weight is 200 pounds. My height is 6 feet. My goal is to lose 5 pounds in 1 month. I have peanut allergy.
Copy menu item.
And then we just use the speech to text feature to get the information and then send it through our database and generate the nutrition plan for the user.
Send button. Hold to record button.
Now the test has been
Text
sent.
has record button.
Now I'm taking the picture
Take
for
picture
the food, and then
Take picture.
it takes time because it needs to do the image analyze. Then
Logo. Page 2 of 2.
we get
After
the
consuming
information,
goldfish
the
bait
nutrition
snack
facts of
crackers.
this food.
Cheddar.
Right now I'm taking another picture for this food,
Take picture button. Take
and
picture.
then it's taking picture and then send the data to our backend and then
Page
do
2 of
the
2.
page analyze, and then we can detect the food is expired because like the best before date is last month, and we can also read the information to the bright
Warning
person.
signs. Expiration warning. These Lay's classic potato chips expired on January 14, 2020.
Now I'm taking the next one
Take picture. Take picture.
and then send it to our backend and then process the image and then return the
Page
result.
2 of 2.
And yeah, it do tell me like this food contain peanut, and also we can still read
Warning
it
sign.
to the bright
Allergy
person.
alert. This food contains peanuts. Do not.
Yeah, that's about the demo. Thank you for watching. Let me pass that to Maggie.
So yeah, this was the application. This of course is in the first version of the application, and we plan to test it more to improve the prompt and to expand the opportunities for nutrition planning, which is to give meal recommendations, to make it accessible to other languages, to make the application accessible offline. And all of these things are our next goals. I hope you liked it.
Awesome. Thanks so much, Team NutriVoice. Super cool product demo. I would definitely recommend checking that out. So thank you. Hey, Emily, how are you doing? Just gonna put
I'm good.
Roger here. So Roger, you won actually the team prize for Anna, right? Yeah. So let's give him an extra congrats. Snaps.
Yeah, congrats. It's great to have you. I'm glad that you guys worked out and you're here. It's very cool to see like things going beyond the hackathon.
Yeah, Emily, did an amazing job organizing it. Everyone snaps to her.
Yeah.
And their team, Eden. Without further ado, Roger, we'll let you kind of take it away. Yeah.
Yeah. Thank you. Share the screen. Oh.
Hey, Brian, I want to see if you can hear my really cool music. I'm going to put on, guess what theme I'm playing.
Yeah, so today I want to introduce to you guys my project and the DevS hackathon last weekend called Scholar Pilot, where I built multi AI agents for researcher. So a little bit about me as a developer. My name is Roger Nguyen. Currently, I'm an undergraduate student majoring in computer science and economics at Villanova University. I was interned in software engineer and also do the research assistant at my school. So when during I do research, I have to read a lot of papers to understand the situation and the problem that the professor want me to work with, like literature review. So I got a lot of struggle in trying to find the relevant papers. I have to usually do it manually, like search on the Google Scholar, and then like got a problem to quickly interpret what the point of the paper and also to organize all of my notes together. So I want to create like an AI support to make the thing more systematic and especially navigate the researcher better. So so my solution is called Scholar Pilot. So as you can see on the screen, it is like a draft of how the components work in my applications. So the first one is for each topic, it will consist of some papers that is scraped and summarized from the school Google Scholar, and also in each papers, the point I want to focus on is some metadata like title, the author, the year, and also the link to the paper. And another thing is also crucial is the large language model generated summary. Um, and below the papers, there is something called the Q&A chatbot. The special thing about this chatbot is like using RAG, it will only like trying to answer a question like within the context of the content from the papers and the topic, and also the history of the chatbot. So then now we will come to each components and to see some screenshots of the website before we come to the demo. So with the topics, I give two options here. So you could create a new topic, so could type in this text here, or you could select some existing topic that already tried before. So the thing here, I haven't like spent too much time on like user authentication here. So it's select the existing topic. It's just all the topic that anyone already tried before. So I want to focus on the functionality with the time limits on the hackathon. So the second part I say is got some papers with metadata, the summary, and we could add a lot of like functionality here if we want. For now, I only like have the delete option if you don't like this paper, but for sure, in more development, I will create more like customization for the users here. And last but not least, is the chatbot that we will focus narrow down with the retrieval augmented generation. And as you can see here. So for the sake of time, because this using a agent, so it might be a little bit slow to generate the answer. I want to show the demo here. So I could search some topic that I find like for example metaphysics, and then you could submit a new topic, and by that time I could come back here. We'll come back to that later to see the result. So now I will spend some time to like explain the thing that run underneath the hood. So as we know now, AI, large language model, generative AI, and especially the agents now are like a pretty trending thing because we utilize the power of large language model and in the context of agents to maximize the opportunity for automation. So I create here like 3 agents to work together and also to take care of the state throughout the agents. So the first one I call the scraping agent. So you put the topic title here so that it could then will scrape on the Google Scholar website. For now, I will just keep like the top 5 papers, and then after scraping, like the data maybe looks a little bit messy, and also I want at this end will be a JSON data, so I use the clean function so that like it could be useful for a couple of next steps. So in the second agent, it's called summarizing. It will generate some concise summaries for quick comprehension. So the way it works here, the script on this agent is quite different. Given the link in the metadata in the first agent, it will now go to each link and try to scrape either a PDF or HTML. If that's a PDF, it will load the whole PDF or the plain text in the HTML and put that into the um, RAG vector database to support for the summarize. I could also like create like a reflect node here so that the summarize could be better like have the interaction like conditional here. And last but not least is the Q&A chatbot. So it's enabled the interactive academic inquiries with RAG. So even though it's just only one node, but it could start history chat with the system prompt. Could also initialize the vector base by taking like all the contents from the papers, the summaries here, embeddings with Hugging Face, and put that into the vector database using ChromaDB, and also the retrieve QA chain from the LangChain. Yeah. So the next thing I want to cover is like the technologies I use to build this AI agent. So actually, most of the technologies here, I'm pretty new with that. Like I just learned LangChain like 2 days before the hackathon, and also this is my very first time to learn, even know about like Streamlit and Fast API. My fortune is that like the sponsor from Grok like had a pretty good API for large language model, and also it's I used the Llama 3 with 70 billion parameters from them for all the process of like summarizing or like um, doing with the Q&A thing. Last but not least, like the Pydantic and the Firebase. Pydantic like to help to like create a schema so that like the data is as formatted as we expected, and the Firebase help me to like manage the thing with the store management. So we might come to check how the thing has going on here in the demo. So as you could see here, the topic is created. It's got like some top papers here with the summary, and you could also ask some question like what is metaphysics, and this one will answer to you based on the content of those above paper. Another thing is wait here I show you to like the select existing topics. This the old topics you could choose, and also have the history of the chatbot, the conversation here. So it's pretty uh, great for you to organize the thing, and also all the history of the paper right here. So I will come back to the slide to talk more about the differentiations. So, so the thing is that as you can see, the user like interaction is pretty straightforward. It's just have one click. You tap in the topic and then you click submit. So it's pretty like user friendly and straightforward to use. Another thing that I think is different from other tool now is like it's called a history and storage. So a pretty neat organization. Even though I haven't done the user thing yet, because like with the time limit of the um, hackathon, but for sure that'll be the thing I want to develop in the near future. That's also what I mentioned here as a soon is a secure thing. Another thing you see in the app now is quite limited in the functionalities for the users, even though it's pretty convenient, but like the user do not have the opportunities to like might be like expand more papers or like kind of editing the thing that created by the large language model yet, except for delete from the list. In the future I want to like some additional functions, like for example you could expand a topic from a paper, or you could try to find more paper that have like a similar content or like spirit with your selected paper. So with that kind of thing, I think like this one is pretty like lightweight and user friendly for users to use. And yeah, that's all I have today.
Thank you. This is amazing. It reminds me a lot of like were our first iteration of our autonomous intelligence private chatbot product that Eden, actually one of the organizers at the Dev Fest that Emily helped build. So it's kind of cool to see where you are, and I'm excited to see all the coming student steps and hopefully incredible things to come.
Yeah, thank you. It's so great for this opportunity to share my project with other people.
Amazing. Incredible talk by Roger. Honestly, a really cool chatbot for research and scholars. So congratulations, hackathon winner. Woo. All right. Next up, we have Jason, Eric, and Angie, right? I'll admit you guys now. Cool. It's great to see you guys. Anyone else from your team, or are you guys all set?
No, we're all set.
Cool.
We're all good to go.
Okay, you guys can hear me now, right?
Yes.
Okay, awesome. So let's just start with the problem. So what you see here is a network log. It's quite large, and it's just a lot of gibberish for the most part. So humans can't really read this. I mean, that's what we're asking you, right? We can't read this. But you know who can read this? Glock. That's what we made here. We're sniping packets in real time. And basically what this is it's an AI-assisted threat detector and network logger here. So this is us.
Yeah. My name is Jason, and I go to San Jose State, and I do encryption and security research.
Right, and I'm Eric. I do CS at Cornell. I have a background in machine learning research in astrophysics and network security research at Cornell Hacking Club.
And I'm Angie. I go to Columbia, study CS, and I built a Gen AI advertisement startup last summer.
Okay, so let's look at the competitive analysis here.
Yeah, so you might be thinking, a lot of people have to deal with network logs on a daily basis. So there are some products out there, including Splunk, Wireshark, Greylock, Datadog, and so on. But these products lack in two main aspects. The first one is interactivity. So you could see the logs, but you can't really ask questions or interact with them, either with your voice to query it or see a diagram of how the threat actually happened and the next steps. Or they take a really long time. And thankfully, at the Columbia Hackathon, we were sponsored by Grok, which is a very fast AI inference tool. So we were able to greatly decrease the time of inference and have a real-time analysis of the logs. So this is some stats on global IP traffic. It will reach 5.3 zettabytes by 2025, and it grows at a 26% CAGR. So as we can see, there is global demand for a tool like Lock.
Yeah, so I can talk a little bit more about what our app using Electron and React.js. And this allows us to be logged through the client side. And we use ScatPy, which is a Python library that allows us to monitor one's network activity. And as we monitor the network logs, we stream it over to our backend server and Fast API.
Okay, so after the initial criteria is inputted into the box there, what ScatPy does is it starts logging everything that it can detect on the network, and it logs everything with a filter that is built by this multi-agent workflow here. So what happens is that first you have the packets that are initially coming in, and each of these are actually evaluated based on these parallel process tool calls here. And each of these tools is actually an expert on a different kind of threat here. So, for example, you'd have some that are experts on cross-site scripting, some that are experts on SQL injection. So these are all evaluated very quickly by these different experts. It's kind of a rough pass. And then after that, it's going to go into this final analysis, which is done by a little bit more sophisticated model. We put DeepSeek in here. And after that, it's going to basically just flag everything into this logger GUI here as either red if it's bad and needs to be checked by the user, or if it's green and can just be let through.
Yeah. So now I can talk a little bit more about the interactive AI experience, user experience that we built around our fully functioning app. So on top of real-time threat detection, using Grok to flag a packet as malicious or not, we take each packet along with its metadata and feedback from the LLM, and we embed it and store it into a vector store. So this allows users to query into their log history with natural language. So we've also added OpenAI's Whisper in order to just speak directly, and someone might ask the search engine to tell them about the different SQL injection attacks that occurred, or anything relevant to the log history that they might be wondering. And using a semantic search through the vector store, it'll generate an output. One thing we want to really highlight and emphasize in our user experience is also how to work towards a specific solution. So we've also gone ahead and built a diagram generation feature where it'll help users visualize how they can take actions towards actually solving the issues on top of just detecting the issues as well.
Yeah, so as you can see here, this is like the general workflow. So once the user inputs that initial criteria, it's going to go into a bunch of different passes to make sure that it actually builds a filter that can be passed into ScapPy without errors. And then ScapPy is going to start filtering all the packets that are relevant to your initial input, which is basically saying that, let's say you don't want to have somebody try to hack into your database. Well, ScapPy is not going to it's going to filter out all of the unnecessary packets, like let's say ping packets that aren't going to necessarily do anything. And then, of course, you have all the rest of the stuff. We have the RAG for basically context searching after each packet is indexed into its database. And of course, we have the different tools here that I mentioned earlier, which are strung together with LangChain, and the processing is sped up extremely quickly with Grok, of course.
Yeah, so as Eric just said, we are powered by Grok, which allows us to infer in real time and also complete an in-house analysis. So another problem with the existing tools out there in the market is that you'd have to rely on their platform. And a lot of the times it would be much natural and more efficient for a log analysis tool to be just built on top of the actual network usage, which was the UI that we demonstrated just now. So just to reiterate, some of the main models we're using includes Whisper AI to complete the multimodal query feature of our app. Second was DeepSeek to produce the final analysis after it synthesizes insights from the expert agents we've deployed in parallel. And the last one is Mistral for our image gen feature. So as for our future steps, Eric, do you want to take the...
Yeah, of course. So right now, what it's actually doing is we're targeting a specific layer of the network here. It's like the lowest one, the one that's closest to the user. So layer 7 here, that's just the application layer. So this would be things based on you running a database or a server. But if you want to target other things like routers, for example, we weren't able to do that in the hackathon based on just scope. But definitely in the future, we want to be able to expand into all layers of the network and give essentially full protection.
Yeah. So that is basically our product.
Of course. Yes. Any thoughts?
Wow, it's a really cool product. I guess I know you kind of talked a little bit about the future steps and directions, but like I'm kind of curious where you guys see kind of like potentially like the biggest impact for this.
Okay, biggest impact definitely would just be for I'd say businesses that are running software platforms, anything that relies on hosting, things like that. I'd say that we have a real market niche for accessibility because of the things that we're giving. We have like voice inputs just for like fast like natural language processing, and we also have also I think a big thing is also just the fact that we're standalone. So one of the things that was quite important that the judges brought up was that some other ones like Cloudflare, they have something called Web Application Firewall. The thing is that if you want to use that, it's going to actually subject you to vendor lock-in. So by us being standalone, people can use this without having to make uncomfortable decisions tooling. So that makes us kind of more apex in this niche, I'd say.
Yeah, and also another thing is we could, so especially when we're creating the agents for different kinds of threats, the cross-site scripting and also the SQL injection, we could few shot prompt these agents so that they could utilize their own inference abilities to level up on threat detection. Because, for example, the Datadog tool, you could visualize the different logs in network usage activity, but there's not really this reasoning feature that could help the user to alleviate and eliminate the threat, because we don't always just want to know the threat is happening, where exactly it is, and our app does that. If you click on the logs, you could actually see the metadata, the origination, but the LLMs also suggest actionable steps for the user, whether business or individual, to act on it. So I'd say that's another edge of our product.
Awesome. Well, I hope you guys had fun. And thanks so much for your time today.
Oh yeah, thank you so much for inviting us. It was great.
Thank you.
Thank you.
Cool. So I think we have 5 minutes till the next team's up. Awesome. So we're back. I see Shirley is here. Hey, Shirley, how are you?
Hi, I'm good. How are you?
Doing well, doing well. So, is anyone else from your team here, or who else is
I
on your team?
believe they're all here, but
So
I don't know how to see the participants.
I see Rebecca,
Oh, Rebecca.
Frey, and
Oh,
is there
hello.
hey Rebecca, how are you? Is it Angela and or Aria?
Mm-hmm.
Yes.
They're both on your team? Okay, cool.
Yeah.
Hello.
Hey, what's up,
Hi.
guys? How are you?
Good, how are you?
Pretty good. So is that everyone or anyone else, or we're good to go?
Yeah.
Good to go.
Cool. Well, I'll let you guys take it away. And
Is there a way to share the screen?
yeah, you can share the screen. So
okay, awesome. Okay. So hello everybody. Today's talk is going to be about how generative AI can play an increasing role in education, specifically in the language learning field. With this in mind, we're going to introduce our product, Found in Translation, and use it as a vector for showcasing the value of generative AI as an educational tool, specifically in the field of linguistics. So to start out, my name is Aria.
I'm Angela.
I'm Shirley.
And I'm Rebecca.
And we are a team of computer science students at Barnard College of Columbia University, interested in creating products to better the lives of those around us. So with that in mind, we specifically wanted to focus on the field of language learning. In the past decade or so, there have been incredible strides in this field. With products like Duolingo, Rosetta Stone, and so many others, linguistic education has become so much more accessible, catering to different learning styles and giving access to more languages than ever before. And also so much more engaging with the increased gamification of language learning that was primarily spearheaded by Duolingo, creating virtual self-contained curricula with an aim of getting users excited to keep learning and returning day by day to keep learning. And while these strides were so incredibly impressive and effective, our team noticed a caveat, namely that most of these programs aren't really catered around the real-life usage of these languages. The languages you learn in classes often don't really line up with the conversations you'd have in real life. There's a lack of an account for slang, secular trends, or the personalization of real-life scenarios. And moreover, this isolated learning environment creates two separate environments between what you learn and your real life, making you less likely to cross that bridge. And we saw generative AI as a potential to cross this bridge. With that in mind, we wanted to create Found in Translation.
So our solution, Found in Translation, it is an integrating language learning into everyday web browsing, enabling learners to practice personalized, pertinent vocabulary through dynamic conversation. Next slide, please. So while building our product, we focused on making language learning a streamlined and easy to navigate process. So during web browsing, the user highlights a word in a different language that they're unfamiliar with, and the pop-up detects the language of the highlighted word and generates the English translation. We implemented this using Chrome extensions for developers and Google Translate API. And if the user wishes to practice this term further in a conversational context, they can press the Save Term button in the extension, which saves the word to Chrome's local storage. And finally, when the user wants to practice their saved terms in conversation, they can navigate to the web app and select their preferences and start the conversation, which we implemented using OpenAI's API and engineering a prompt that would curate a dynamic conversational chatbot that incorporates the user's selected words into the conversation. So now we can move forward into a product demo.
Sorry, one second, I have to switch what I'm sharing. Okay.
So here's the interface for our web app. On the right, we have a language text box. So for example, if we want to practice Spanish, we can just type Spanish into there. And then on the left are those saved terms from the user's web browsing activities. For example, if we want to practice the words gato and cucaracha more, we can just star those two in the table, and then they'll appear in the vocabulary words text box. Finally, we can just press start conversation, and then the AI assistant will greet the user and start out with a few questions that incorporate those two terms into the conversation. The user can then respond with whatever they think is the most fitting, and then the assistant will respond and then maybe provide some more questions. So this dynamic back and forth conversation is something that we find really important in furthering users' ability to use these important vocabulary words in their everyday lives. Now, if we pull up a website that is in Spanish, and for example, if the user is browsing the website and they encounter a word that they're unfamiliar with, they can simply highlight it. And then the pop-up should appear in the top right.
For
And
some
then,
reason it's not showing. But
yeah,
yes,
it
the
might be
pop-up
something
does
to
appear.
do. It
But
could be
you can
something
describe it
with
anyway.
the screen sharing, but essentially when the user highlights the word, the extension appears in the top right corner and it automatically detects the language of the highlighted word and provides an English translation. And we did that using Google Translate API. So it provides really streamlined language learning processes and is very integrated into the user's everyday web browsing activity.
So you might be wondering, why does found in translation matter when there's already so many great language learning platforms out there? So let's start off with translation. So as we all know, Google Translate is a great platform to get instant translation of different words, and it's super powerful and really accurate. But users currently have to copy and paste words or phrases into the translator, and this involves a tedious back and forth tab switching process, and it's just time consuming and just frankly quite frustrating. But with Found in Translation, we provide a built-in Chrome extension to deliver instant real-time translations powered by the Cloud Translation API. So this means that there's no more switching back and forth to different tabs and just provides a much more streamlined and instant process. Now, in terms of language learning, apps like Duolingo and Babbel, while they create a really great and immersive in-app learning experience, they often lack the personalization and real-life application that a lot of language learners seek. For example, Duolingo provides a default learning module that all users uniformly follow. But this lacks personalization and also the terms that they learn don't really integrate into the user's daily life that seamlessly. So with Found in Translation, we have 3 high points. For example, with the Chrome extension, this could leverage users' everyday web browsing activities and turn them all into learning opportunities. Whenever a user encounters a word, they can instantly get the translation and add it to the glossary, which is highly personalized to them because they curated it themselves. And then the third point is then they can then practice these words in a conversational context with an AI chatbot, which is usually the end goal for a lot of language learners.
As we look ahead, there are several ways that generative AI can further enhance language learning. Here are some key ideas that can help shape our future. First of all, the generative AI can highlight areas of improvement. It's able to identify mistakes and provide corrections instantly. They're also able to notice users' patterns and provide suggestions to help break out of these incorrect patterns. It can also identify users' strengths, which will help them become more confident when speaking the language as they understand that they have a strong foundation in certain areas. This also brings us to the personalized curricula that AI provides. Lessons are customized, so this means that the progress, strengths, and weaknesses are adapted to the user, allowing for more effective learning. By analyzing conversations and providing feedback, the AI can tailor lessons to help users learn natural speech patterns. This includes slang and regional variations, allowing the user to speak and seem more native when speaking. Because we can use AI, we can also reach a wider audience. It can be more accessible. With AI, more languages, including less commonly taught ones, can be supported without needing additional human resources. It's also easier. With the browser extension, users can learn words immediately and put them straight into practice. With all of these advancements, AI can make language learning more personalized, efficient, and inclusive. These are just some ways of how found in translation using the generative AI can help create an instant and novel learning experience for all of our users.
Thank you so much.
That's amazing. What an incredible presentation, and thanks so much. I feel like this technology could just be like super impactful. I guess if you had to kind of share like a few takeaways, what would those kind of be like from you guys from like building this project?
Well, I mean, I think kind of as our presentation indicates, we really learned just how valuable AI could be. I mean, we kind of walked into DevFest not really knowing exactly what we wanted to do, but knowing that we wanted to help others. And when we realized how AI could really add this element of personalization, I mean, it kind of felt like walking onto a gold mine. It's just so inspiring. And, we're really excited to see how that can further play a role in linguistic education in the future.
Yeah, and I guess I can also add a bit to that. I think that we can also see like a lot of connection between our personal like language learning journeys with the technology that we're building to help us and help other people. Because a lot of us, like I know a lot of people who learn languages just by conversing with AI, and it's actually a really great translation tool and also conversational tool. So I feel like bridging like our real life and our real learning experiences with this product that we're building, it's super valuable. And I think that it was a really rewarding experience in terms of that as well.
Awesome. And I guess one thing I really like about your product is that it's like really simple. Obviously, I guess, and it's also like could be just like really useful for like everyday people, who might just not know like a language that might want to like find something really quickly. I guess we kind of talked about this in person, but if you have any ideas on like if you had more time, what you'd kind of do in the future to build out different things, like what do you think would be like interesting,
So I think one of the things that we were really discussing for like future endeavors is to maybe have a way for an AI summary to be generated of the conversation, and that way the user is able to receive instant feedback on whether they use the words correctly or like whether there's kind of a better way to phrase something. And so we thought that like leveraging AI in this way would be useful as well. And then having the user being able to look back on those conversations and look at what they could improve on so that they can apply those into the next conversation. I think it would also be useful to kind of implement a way to use flashcards so users have multiple ways of learning different languages. Like the AI can we can connect the Chrome extension to the flashcards and users have just many ways of using these words, and we can generate sentences so they're able to learn using separate sentences as well.
Amazing. Well, thanks so much for your guys' time today, and I personally really enjoyed this presentation, and thank you.
Thank you so much.
Thank you for having us.
Awesome. What an incredible talk. So yeah, I think we've had 1, 2, 3, 4, 5, 6 DevFest talks done. We have 5 more to go. Maybe we'll do like a vote in our Slack channel. You can kind of say which talk you like the most. So join our Slack channel, And this is actually like a really incredible talk. I feel like Just personally, like there's been so many times where I've wanted to actually like understand what a word meant in a different language, and I didn't really know, and then like didn't really want to like go like look up like thesaurus. So this is actually like a really cool way that I could just do it on the fly in a browser. And thank you guys for building that. So I'm going to keep this Slack channel QR code for 1 second. Then we're going to essentially go the count. Hello, we are back with a bang. So here we have Team iAssist. Is that correct?
Mm-hmm.
Yep.
Awesome. So I guess I'll let you guys take it away.
Yeah, sure. So I don't think anyone our other group members here. That should be fine. Presenting. All right, perfect. So, hi, my name is Shiom, just in case you guys didn't know, and we have.
My name is Sunu. I'm a first year at the University of Connecticut studying computer science.
I guess I just say the same thing. I'm also a first year studying computer science and engineering at the University of Connecticut. We have two other members not here at the moment, so we'll just go ahead and go off from here. So the project we made is called iAssist, which is meant to serve as a visual assistant designed to provide real-time navigation for the visually impaired. And we use this by using multiple tools that are all AI powered, and our hope is that this will make the lives of those who are visually impaired a little easier and make them more comfortable in our world. So, this is the introductions. I'm going to skip over this for the sake of time. These are two other members who aren't here right now, but you can read a little bit about our bios. And let's start.
Yeah, so the problem we are looking to address was the inaccessibility when it comes to um, the visually impaired, where over 2 billion individuals are actually affected by visual impairments, and a significant portion of these individuals also face navigation challenges due to the high cost and limited accessibility of existing solutions. And some of these solutions, like LASIK or guide dogs, um, remain expensive.
Yeah, sorry, just get it back here. There you go.
So our solution, iAssist, is a virtual assistant with text-to-speech functionality in real time, which analyzes and advises its user where to go and any objects or surroundings that they should be careful of. So how our application actually works is that we have a initial camera capture where the application can recognize and initialize a live camera input and then proceed. This uses OpenCV to support its main functionality. We observe the scene, which uses Ultralytics YOLO V11 for object classification, and it can distinguish between important and insignificant objects, such as like a moving car versus just like a water bottle. And finally, we have a prioritized advice, which is just a queuing system that prioritizes the most important messages that should be declared to the user, while trivial factors are left behind.
And yeah. So now to go over the actual architecture. So I'm just gonna go into a little more detail and hopefully that will help those who are a little more curious about the inner workings of the project. So the way it works is that we usually have a streaming device, which in this case we often just use our phones because that's the most accessible way to do it. And whatever streamed through the phone will get first put in this part right here, and that's done through OpenCV, which allows us to actually take video capture. Then we use a model called YOLO, which was referenced before, which stands for You Only Look Once. It's an open source model often used for object detection, and it performs very well in many benchmarks, and it's sufficient for our uses. So once we actually detect objects within the video frames, we then move it to and we start analyzing. In this case, we use a memory buffer where and we have two separate memory buffers. In this case, we're using a tracking memory buffer, which in this case we analyze frames within certain like a certain amount of frames, and this is a um very fast. And what we essentially do is we take the x and y coordinates and we convert this first the scene that YOLO gives us. It makes it an actual useful scene that we can actually analyze. We also look for movement detection because that's also very useful information that we would like to use for our output. In this case, we just take we find the objects and we compare different frames, and we take the derivative and look for changes sufficient enough to alert that this is a moving object.
And then once we take that and then we move it to the second step where we then take a longer memory buffer, which in this case we call it the analysis memory buffer. And here we analyze multiple frames, so a much larger frame set, and we actually do scene summarization. And this is done for two purposes: to make the scene have more context, so obviously it's more accurate. But also is because if you notice, we have two different threads going. Because this is a concurrent app where we have an LLM stream slash image analysis stream over here. We also have a TTS stream, which I'll elaborate on a bit later. So because of that, we need to align the timings just so they line up correctly. We then use the scene summarization in the scene summarization as context for an LLM call. In this case, we actually use Grok because it's just faster because it's an inferential model, so it gives us faster results. So we use an Llama 3.2, which is an open source model, and we do that through an Ollama client to get back a very specific response. So we did a lot of prompt engineering to make sure the process and the actual navigation instructions are as useful and concise as possible. And then we make sure we have a priority queue that first looks for keywords inside the Ollama navigation instructions. And in this case, let's say in navigation, we noticed that there was an emergency, like a car going by. That would have a higher priority queue and thus would have higher precedence. And in this case, would be the first message the user see that compared to like something a bit more not as useful. And then once we have all this information, we actually feed it into a talk to stream system that's always running. Now this is a much slower system, as you can imagine, because actually speaking out and convert the text to speech and actually saying the message takes much longer. So in this case, we use Kokoro, which is a very high performing open source model on Hugging Face. So this is done through a Hugging Face pipeline, and it's very performant and it works really well for our use case. And after that, if everything looks good, that's the whole tech stack behind our model. There's some smaller details here and there, but this is as much as people would like to know. And one thing, if we do have time, I don't want to do right now. I could also show a demo, but I'm here out and see what if time allows for it.
Yeah, I think we should have some time. I think you guys can go like a little bit over if you need. So.
Got it. Perfect. Okay. Just give me a second. Now, I need to actually present my screen here. Actually, you know what? If you want to hear audio, I'm gonna have to. I'm not sure I can show audio if I share my entire screen. So right now we'll just see the text, but it should be fine. So this is the actual code, and just for right now, we'll use a Python command to make this as smooth as possible. But once we run it, let's load. There. So it should connect to my actual camera, which and I hear some audio, but as you see here, they're detecting all the objects that are in my surroundings back here. And yeah, there's objects here, and then the actual instructions are being played through the audio. Because I'm sharing my screen, you can actually hear the audio. If I can find a way to set that up, I would love to do it. But right now, that's how the actual program works. Let me stop sharing my screen.
Awesome. Is that all or anything else?
I really wish I could share my audio, but the way screen sharing works on this app at least is where the only way to share audio is if I present a tab. and I have to open the app and set it up, but it probably won't work for this case. But yeah.
It's cool. I mean, it's a really cool product. I mean, I saw it live when I was visiting Colombia last week, and yeah, I think what you guys built is really amazing. So congratulations.
Thank you.
All right. Well, thanks so much for your time, and appreciate it.
All right. Thank you.
Thank you.
Cool. So we'll have a 10-minute break, and then after that, we'll bring on Harvest Hub. Hey guys, we're back. And we're very excited to be here. So next up, we have Team Harvest Hub. Let's admit the team.
Hi.
Hey Justine. Wow, long time no see.
Wow.
How are you?
Really good. How are you doing?
Doing pretty well today. Doing pretty well. So
Hi, Natan.
doing great. Hey, how are you?
Good.
Wait, is Kenny joining or is it just us three for today?
Kenny's in class currently, but he's probably gonna dial in at some point today. He'll be here.
He'll be here. All right. Well, I'm excited, and without further ado, let me get out of the way so you guys can get started. Yeah.
Alrighty.
Thanks
Let
so
me
much.
quickly test my screen. Alrighty. Can you guys see my screen?
Yeah, I can see it, Nathan.
Cool.
Yeah.
Full screen?
It just has to like load all the way. Right.
Perfect. Yeah, full screen is good.
Yeah. There you go.
Does this work?
We're actually not able to see the full screen, Nathan.
Interesting. Okay.
I don't know
It's probably something with the slideshow, but I can just present it or quickly share my screen. Sorry for the wait, guys. All right. I think that should be a bit better. All right, Justine, whenever this shows up for you, feel free to take it away.
Perfect. All right.
Yeah. There you go.
Perfect. Hi everyone. My name is Justine. I'm a current student at Columbia University. Joining me are my lovely team members, Nathan and Benjamin. We're all first-year students at Columbia studying computer science. We're super excited to be here today to present our project that we actually built in 24 hours at a hackathon very recently, where we were able to meet Natan and the rest of the Anote squad. So super happy to be here and share our AI agent technology that we've built with the hopes of helping you learn what students are doing nowadays regarding artificial intelligence.
Fantastic.
All right, so let's introduce the problem. As students, like what exactly are we trying to target with our AI technology? The first thing that came to mind for us was climate change. A lot of us are currently working in different research places around Columbia University, and we're all really passionate about contributing to the fight against climate change. With that being said, we sought to create an app that helped small-scale farmers, as we know that a lot of the farming technologies are currently only being applied to industrial farms or those who have the capabilities to have access to these kinds of technologies. So, recognizing that there was a need for small scale and medium scale farmers to adapt their technologies more quickly, we tried to build kind of an app or a platform that let them become one, more knowledgeable about what farming techniques could help them out there, but then secondly, give them the incentive to change their farming techniques so that they can develop farming styles that are resistant to climate change. And that's why we built this app. So Nathan, why don't you tell us a bit more about this like platform that we created?
For sure. Thank you, Justine, for that great intro. So we built Harvest Hub. It's a social and analytics platform to empower small-scale farmers to fight climate change. So I think the key thing that was mentioned earlier is number one, we have to provide them with knowledge, and number two, we have to incentivize change. So we're really thinking about those two things, and how can the small-scale farmer really change, really adapt their techniques to the growing climate change problem. Historically, a lot of the traditional techniques that they've been using have sometimes been outdated based on new climate data, and we want to inform small scale farmers with this new data. So what does our platform, what does our product actually do? So a farmer is able to log in into Harvest Hub and input their farming metrics. So how does their farm look like? What type of crops are they growing? What sort of techniques are they using? What does their water usage look like? What is their irrigation? What does their soil techniques look like? And so we take all that data, we plug it into our AI engine, and we look at two different things. Number one, we look at climate data, historical climate data. So for farmers using a certain technique, what are the implications of that? And number two, we look at local dynamic updated data. So we scrape the web, we find articles, research reports, anything that can really tell us key information about what's going on in their local county. So we want everything to be personalized and tailored to them. And so we take those two things as well as their inputs, and we give them recommendations. So if they're a farmer in Beaver Creek, Minnesota, and they're looking at and they're using a certain amount of water, but there's been a drought recently, or there's been like a pipe leakage, it'll tell them, okay, here's what here's what you should change into, and here's what we suggest. So that's the first part of our platform, giving knowledge, and the second part of our platform is really inspiring and incentivizing change. And the way we're doing this is through creating a social platform. So we'll demo this later on, but the farmers can look at what other farmers are doing, see what they're changing based off of our recommendations, and from there they can trust their fellow farmers, not just this AI engine that we're using to suggest recommendations. Benji, do you want to introduce the product as well as the AI engine?
Yeah, sure. Yeah, you guys hear me all right?
Yes.
Alrighty. So here we have Linda here. Linda is going to be our example farmer for today. So she's from Beaver Creek, Minnesota, 55 years old. And, she's a normal small scale farmer. She works primarily with rice and green beans. And she's noticed that as of lately, her crop yield, she's not seeing as much success. And perhaps climate change has had something to do with that. So she decides to download Harvest Hub. And again, we're trying to advertise their farmers here, and we acknowledge that the process should be as simplistic as possible for them, but we really do have a lot here going on in the back end. So the moment that Linda decides to input her data, like her farm, what kind of crops that she's growing, we kind of have this really unique multimodal agent approach, where first we use Gemini to do our web scraping and our news sourcing. So we're going to be looking at what kind of data could be impacting her farming techniques. So again, as Nathan was saying, what if in Beaver Creek we had a cattle outbreak, cattle disease outbreak that is affecting the way that cattle has been eating her crops lately, or maybe the way that drainage pipes have had a leakage and could be impacting the growth of her crops. This is all regional news data in combination with just the regional climate change data. For example, we know like maybe Beaver Creek, Minnesota is going to be more prone to colder temperatures as time goes on. We factor that in along with the types of crops and the techniques that she's using into a reasoning model. And this is all done in the cloud here. This reasoning model is going to output what she should do for each one of her crops. And then following that, we have another summarization model that's going on in the back end that actually takes all the answers for the crops and outputs it into a really nice, convenient, and structured response.
Fantastic.
So we take this in combination with our basically our user recommendation engine that we have on the right-hand side to try to not only give a nice personalized AI recommendation, but also show that people nearby her are actually using these strategies, and maybe one of her friends is seeing some really good results.
For sure. All right.
So yeah, here we have some examples here that our models could be using to see how real-time news could be affecting their crop techniques.
And yeah, we that's Harvest Hub. We are now going to move on to a live demo to show our product. And for us, we really wanted to demonstrate how AI can really make an impact in many different places. And so this is Harvest Hub. Benji, do you want to walk us through what's going on here?
Yeah, sure. Let's go through it. So again, we're going to be Linda here. Let's select rice, maybe corn. And we're going to select our irrigation techniques, drip irrigation, composting, why not? Flood irrigation for corn, and soil management, no-till farming. We save our techniques to the database, and we press give recommendation and extracting this process, making it as easy as possible. And here, right here, we see that for corn, we should change our strategies. And we even see, again, the University of Minnesota actually discovers, or we see that given our little web scraping engine here, we see that the University of Minnesota has made a study on beavers and ecosystem stability. So maybe she should switch up her routes with corn. Again, we can even see people nearby. Who knows, maybe we know Taylor Swift. Click on here, we can even see other people's farms, So maybe let's see whether Simos is actually doing a good job with his farming. on the bottom here, we can see when people switch over. So again, we're really trying to incentivize the idea of community and just seeing what other farmers nearby are doing.
Thank you. That was our product. We really appreciate Natan and the whole Anote team for inviting us here to speak on how AI can really make an impact on multiple places. Here's our emails information. And
Awesome. Yeah, I
Benji,
mean, as a team, we're super excited about building this technology. I think, Anote is doing a really good job of showing all the different technologies that can come out of the AI revolution. Hopefully, Harvest Hub can give you a sneak peek into what 24 hours can do. I mean, if we're able to build this thing to help, the agricultural sector very quickly, we're super excited to see all of the new technologies that'll arise, and hopefully young people like us can be a part of that too. So, once again, like Nathan said, we'd like to extend our gratitude to Natan and the entire team for having us. Super excited to keep building.
thank you.
Super excited to see what you guys continue to build, and thanks so much for kind of coming here today.
Of course.
Yeah, absolutely.
Thanks. See you.
Bye-bye.
Thank you.
Amazing. Let's give it up another time for Harvest Hub. Woo! That's an incredible presentation. They should be really proud of the work that they did. And obviously, you can see a huge impact on the agricultural sector. So next up, we have Jawad, right? Is that correct, Jawad? Awesome. Jawad, how are you doing?
Good. How are you? Nice to meet you again.
Doing well. So is anyone else from your team joining? I see a few people in the waiting room. So
Yeah, there is also someone, Abergalib Ohi. He's my teammate. Yeah.
Yes. All right. Cool.
Hello there. Am I audible?
Hey, how are you? Yeah.
Nice to meet you again.
Yeah. Nice to see you again. All right. I'll let you guys take it away.
Okay. Let me share the screen. Just a minute. Can you see the screen? Excuse me.
Yeah, I can see it. I can see it.
Oh, okay. Yeah. Oh, can you start?
Okay, I'll start then. Well, welcome to our presentation. We are Forager on the Go, and I am Abar Galibohi, and this is my project teammate, Jawad Zaman.
Hi.
And our project, Forager on the Go, is basically for people who venture into the wilds, for people who go hiking into the forest, or professionals who work in isolated forests or hills, or people who sail the seven seas. And while you're doing all this, there's times when you might get lost and you might not have food. And that's where our web app, Forager on the Go, comes in. And the purpose of this app is when you're like lost in the wild and you need food, you can like scan the image of maybe a mushroom or a fruit or any animal that you don't know if that is edible or not. And after scanning and scan and input that image here, it will identify what it is and give you information regarding it. Now my teammate Zawan is going to explain how that happens and give you a demo of it.
Okay, thank you. So suppose you are stranded in a jungle, you don't have anything to eat, but you can like forage food from your environment. So what if you had the power of AI in your hands? So that's what we are building right now. We are creating a web app which in which you can take a picture and upload it, and it will scan that image and tell you what species of that animal is, or it could be any animal, plants, insects, berries, flowers. It could be anything. Like this model can identify almost anything. And so like I'll give you a short demonstration, get started. So when you come from your home screen to over here, I'll just upload an image as an example. Suppose yeah, this is a picture of a cat. Like I'll upload the picture of this cat over here for just for this demonstration and hit predict. Oh wait, just a minute. Let me get a real picture, as in like a mushroom, which is easily available. Mushroom, poisonous images. Suppose this one. Let me download it. Save image as like I can save it as anything. It this AI can detect what image it is. It doesn't need the actual name of the image. So I'll upload this image and predict. So it's running through and it will tell you that it's an agaric mushroom. It's 89% sure that it's an agaric mushroom, and like it can be found in the wild. However, this is a type of poisonous mushroom, so it says that some agarics are edible but and safe to consume, but others can be poisonous. So it's essential to exercise extreme caution, and like it will give you if it's edible or not. It will tell you what are the other usefulness of survival and the precautions, like avoid touching, don't eat raw, and what are the alternative survival strategies, like you can find a source of water using this mushroom, like knowing where this is, and you can build a shelter, start a fire. So in summary, like it will tell you everything that you need to know about this mushroom variant. And for this model, we are using, like for the image identification, we are using ResNet model, which can take in picture and tell you the species. And for the generated response of the description, we are like putting this through an API, the Grok API, to the Llama model, which will then create this response. And moreover, we can also access this website through our own GoDaddy domain, goforager.us, where you can like access it from your phone or like anywhere. And we're trying to integrate an offline like an offline version of this, and Ohi will describe more about it.
Okay, so as you know, the most important part of of our project is the offline part, because you're really going to need this app or this website when you're lost in the forest or any isolated place without internet. That's why the offline part is important. And for that, we're planning to um, make for this we're making the Vision AI model that is going to compare the images. It will be built inside the website or the app, so it can, when you input the image, it can identify it, and then it will use a mechanism where it will use a mechanism where it can auto detect your location while you still have the internet, so that when you go to a place, for example, a forest in Africa, it will auto detect your location, and before internet gets cut off, the generative AI will collect information from the web about all the species that is like in close proximity of the location you are in, and then the data about those species, about whether they're edible or not, and everything about that is going to be saved in the cache memory of your device, so that even when you don't have the internet, it can identify what that species or what that fruit or berry is, and it will still give you information by pulling it from the cache memory of the device, and that's how the offline part is going to work.
So as we are developing this model more, like we are trying to expand the databases so it can get more get access to more information. And about the cache memory, as he described, the images that we're uploading are being saved in the code. So like even if you go offline, if you search it before, you can easily access those again. Like the AI model, the generative part may run online for like when you're connected to the internet, but for the image detection, it can run even when you're offline. And like we made this app so that travelers and adventurers are safe and smart when venturing outside, and hopefully it can help a lot of people. Like happy foraging. So if you guys have any question, we're welcome to take any. And this has been great talking to you. I'm Jawad.
Yeah, it's a classic example. A lot of times people have the age-old question: when you're in the jungle and you see a bear, what do you do? Do you run faster than your friend? Do you put your arms up? Depends on the type of bear, and maybe you don't know the type, so maybe you'd want to take a quick image and understand really quickly what to do. So I think this is a very cool project.
Thanks for having
Thank
us.
you very much.
Cool. So amazing talk. I learned a lot about that, and honestly, it's something I probably would use if I was in like the wilderness. So thanks so much. Essentially, we're going to take a quick break. Thank you, Jawad and Abrar. And we're going to take a quick break. And then I think at 6 p.m., so in 20 minutes, we're going to have the last two presentations. Yeah. Hey guys, we're back. And yeah, we're excited for the next presentation. Can you hear me okay? Cool. So I'm gonna admit Kashal. Hey Kashal.
Hi, I'm Kaushal. I'm a master student in Colombia, and so let me take you through my project. Can you see my screen?
Yeah, I can see it.
Yeah. So I was doing this course on agentic AI, and I was looking at a lot of research, which is going into building these systems. Um, and the motivation for the course was to like add build systems which could help simulate and bring agenting system into enterprises, but I did not really have a good project where I had applied agents. And so I would like thank my team who were like three developers were building an application outside of agents. And I kind of like convinced them to let me be their part and bring in some agenting systems which may or may not help their kind of use case. So let's first look at their workflow, their idea, and the idea was to encourage nutritional donations to food pantry through a reward system like a small coupon. So users would have excess food, restaurants would have excess food. They would like post that excess food to our app that had built, and based on the nutritional content and the demand by the food pantry, we would send them coupons based on their donations. So given this workflow, I was supposed to bring in agents and see how they could optimize this application workflow. And there were two kind of areas where I thought an agent would be really useful. So the initial idea was dependent on the food pantries to rate the food and to give a reasoning about what's nutritional, what's not. And so I thought we could remove the human in the loop, right? Because food pantries should not be specializing or hiring nutritionists to judge food. It can be easily automated by an agent. And second is that food pantries are not tax heavy, right? Like they don't want to keep up go to your website and keep on updating their availability. So can we ask them to update their just websites, their website which is already present, and we would scrape that information from their websites using an agent which could serve the web and specifically specialize in surfing websites built by these pantries. So let's look at the rating system and my approach to it. I would also, in the end, would like to know your ideas and people more experience with agents and how would they implement it. And so there's a lot of research when it comes to like LLMs that they need super good context, right? So if you look at libraries coming out of Stanford like DSPY, they specifically try to optimize your prompts. They try to optimize uh, the output of the LLM using a few shot learning or searching through the space for examples. So when you want to develop an agent which can debate or reason about the nutrition of what you uploaded, you need to find good prompts, good examples, and a good context. And so to develop a good context, I thought of stealing some data from the US government. So the idea is US government already has this branded products which have their nutritional contents listed over here. So what I thought is let's scrape it, put it into a vector database. In this case, I'm using Chroma. You can see over here there are the branded food items and their corresponding nutrient contents. And so the workflow is something like this. You use a object detection model. In this case, it would be better to use a next generation convolutional nets or a combination of connext with VITs, but didn't really have the time to implement. So I resorted to an VLM from Llama, add the context using Chroma, And this context, the idea was these constructs would help the agent reason well about the nutritional contents of the whatever image you uploaded. And so let me quickly demo this. So I just quickly downloaded these two applications. One is this burger, and then we have this like a mix of healthy food items, and we would hope that the agent is able to do well on this. So let me just upload this again to make sure. So let's upload this burger, and like kind of see what kind of reasoning it can come up with. And so this is a really last minute work where I wanted to like show you what kind of reasoning and what kind of context we're passing to the agents as well. So in over here, what are the detected items? We see burger buns, cheese, beef patty being detected, and based on that, so there was similarity between the items that are detected and a veggie burger. And based on that, we see that these are the nutritional contents, and in this case we hope that LLM has been well pre-trained, so that it understands what should have high nutrition, what should have low nutrition, etc. And we see this kind of a reasoning coming out, right? That the food items have a moderate amount of high energy content, has being this, etc., etc. And so I was not able to print out everything in this last moment, but we also provide like values for what's considered high, what's considered low. And the hope is that this context helps the model reason well. So this was one part of where we like implemented agents. Where's my slides? So sorry. This is like, let me return back to my slides. Interesting. uh, all right. Yeah. So the second idea was taken from this paper, which as we said, right now we have deep reasoning models, deep research models from OpenAI, where you could like ask the model to research about a lot of things. But that idea came out of this paper called Storm, where where you ask it certain topics, and it would like create various perspectives from those topics. And then they had this reasoning kind of a multi agent system where based on various perspectives the writer would write stuff. It would then give it to an expert, which would analyze what the writer has produced. It will analyze various perspective, and then give that back to the writer agents. And in the end, what we had was a Wikipedia like solutions along with references. And being inspired of the by this, what we were trying to solve the problem of like scraping pantry information. And so I was trying to build a very simplified version of this, where the context would be the current web page, what all actions, so basically what kind of buttons can the agents click to go to the next web page. um, the previous web page was also added as a context, and there was a model which would reason whether do we have all the information or not. If we do, we give out the output. Else like there was I created a mad system where one agent was debating whether we should go back, or another agent was debating whether we should go ahead. And this is a very simple kind of system, because we only had I think 24 hours to implement this. But did it work? No. Like, but from my experience, it would either go to just like try to traverse only 2 or 3 websites and give up, or like just find all the information in the first website it kind of found out. And this was the kind of system I had built. There was an action limit, and based on this action limit, it could either go forward or backwards. And for each kind of iteration, we would get the context from the current web, find clickable items, find previous items. And the first model would debate whether we have enough content or not. If we did not have enough content, we had this multi-agent system to debate to debate whether we should go back or not. And I did see a few iterations and few improvements in the overall loop, but it wasn't that great, right? And so my next step, if I were to take this project up, is to take inspiration from this doc ETL kind of systems. And so what they do is they also trying to solve something similar to like like information extraction from documents, but they have these powerful operations of going through each document and mapping various items. If the map is not that good, they would like decompose the operation into multiple operations. And so my next steps, if I had to take, was to like incorporate a doc ETL type system for the web search. And so just a quick demo for the web search. Sorry, I just prefer like prepared last minute. So uh okay, so this is the kind of system, a single web page, and this is only the information extraction reasoning kind of model works, and it's not satisfied. As you can see, there are certain information it was not able to find, but right now I don't think the action, I could get the action thing running for this demo. So otherwise, because these items were not found, it would have gone through various websites and filled these items out for various pantries. So yeah, that's it from my side. I would like to know your views on these systems that were built, your experiences with building something similar, and yeah, any other suggestions would be nice.
Wow. This is an incredible presentation. Thanks so much for your time. I guess we are almost up out of time, but I guess was there any kind of like key takeaways that you think like the audience should kind of know about? And what would you kind of do if you had like more time? Yeah.
Yeah, so more time, definitely try to implement something like a static operations like map and reduce, which like a paper like doc ETL proposes to handle big documents. So over here, the biggest problem the kind of web agent faced was um, just was not able to handle the large amount of context we were feeding in. So we would need something, an operation like reduce, which could summarize relevant information, break it into chunks. So a good thing which I feel like the paper does is it brings and automates this process of reducing a document into multiple chunks, giving it to the LLM, and then having a group operation where it could group all the information. So I think something like that was really needed with the agent. With the food nutrition information retrieval thing, I was pretty satisfied with the performance, but only improvement I would do is like change the context, because if you look at the context, it's very mechanical, right? It doesn't. It's just a list of nutritions and the amount of nutrition present, but I don't think LLM was able to kind of gauge a lot using that information. So I think yeah, I would try to shorten that, like like I would like limit to certain nutritions that it was versed with, because again I was using a smaller model, and find more examples and find better optimization using few short learning. I mean, that's kind of what I think would have improved the results.
Very interesting. Very interesting. Well, anyways, thanks so much for your time, Kishal. I really appreciate it. And yeah, best of luck.
Yeah. Yeah. All right.
Awesome. So we have one more presentation left from AI Day. In 10 minutes, I'm going to put the timer countdown on, and we'll be back soon. Hello, live from New York City. We have the last man of the hour, Darren. Hey, Darren.
Hi, how you doing?
Doing really well. How about yourself?
I'm doing good, you know. I'm ready to talk about what we've been building and get to talk about insurance and AI. That's like a blast. That's what we're looking forward to.
Looking forward to hearing from you. I'll let you take it away.
Yeah. I have two other team members. Should I have them up here?
Yeah, what are their names again? I'll add them.
Yeah. Brian, Tran. Yeah, awesome. I think this is good.
Hello, can you hear me?
And is
I hear you.
Kian also on
Kian,
your team? Yeah.
yeah, Kian Tran, yeah.
Cool.
Awesome. Yeah. Well, yeah, we'll go ahead, try to keep things brief for y'all. Um, but here is our presentation on AI agents for health insurance. This is going to be largely a vision-based thing. Since in our hackathon we weren't able to get to everything, but our vision for an AI-powered health insurance broker. So here is us. This is Kian, Brian, and Darren. We are students and we participated in the DevFest hackathon, which is where we met Natan and got invited. And yeah, let's jump into what our problem is. So the problem is health insurance is complex. Um, I don't know if you guys have ever looked at like one of your plans, but what are all of these terms? Like, what is coinsurance? What does your network mean? What does PPO mean? And this is on purpose. Insurance companies make it purposefully hard to figure out what your plan covers and how much you're covered by, because if you use your plan actively, they are losing money. And that also means that you are probably losing money on your plan if you don't know how to pick the right plan or utilize your current plan fully. Here are some problem statements that we found of like people saying there are times where I feel overwhelmed because I don't know how to ask for help for my insurance plan. Reading the formulary, and this is something that Brian will get into later, which is the main crust of our project. But reading the formulary is really hard and really long. And a survey of like 5,000 Americans showed that nearly 40% of insured Americans, though they already have insurance, struggle to understand what they do. And our claim is that it is not your responsibility as an employee or a founder to waste your time worrying about health insurance. Enter brokers. What are insurance brokers? Brokers are licensed experts who are on your side. Um, so if you have these questions about what your insurance plan covers, you tell your broker, hey, I got a family of three, my grandma's sick, I'm in New York, and your broker like answers all your questions. Um, What's the catch? Well, brokers are free. You don't have to pay anything to use their services, and they get paid on commission. So if your plan costs, let's say, 1,000 a month for your Anthem plan, they get paid typically like, let's say, I think like 6% on your monthly premiums. And that's why they typically work to get coverage for businesses, because um, with a business of, let's say, like 10 to 20 employees, and the business sponsors $1,000 per month for each employee, brokers will make a lot of money just by helping one company enroll in benefits. But this cost is paid out by the insurance company, and you as the person who uses the broker will not have to pay anything. Here's a little bit of what they do. They'll recommend plans for you. So they typically work with insurance carriers directly to get the best prices. They might help out with enrollment, and this is typically for businesses. They will handle underwriting, which means like if you have like less than this many employees, are you qualified for this plan, so on, etc. And this is what we want to get into, providing support and explaining coverage. So during the plan year, after you have enrolled, um, brokers are there to answer questions year round about what your plan does for you. And this is what Brian will go into with the Demystify AI agent.
Hello, can you hear me?
Yep, you're good.
Okay, so behind the scenes, Demystify AI is powered by OpenAI's ChatGPT researcher and pre-processed healthcare insurance data. So next slide. So this is a demo, and the first thing you enter is your insurance coverage, and then you also enter what type of prescription drugs you're most interested in. And then after you do that, It goes through all the insurance data that we pre-process, and it gives you a detailed report, answering all the questions that you want to know, making this process more accessible. And so the main thing is that employees want to know what type of prescription drugs are covered in their plan, which is why that's one of the main features of our product. And so this is sort of the implementation. So first, like I mentioned, you put in the seed medical insurance data, and then we pre-process it so it's easier for the LLMs to understand. And then we search through the drug formularies in order to extract the most relevant information. And then we at the very end we provide a summary of the benefits for the consumers.
Yeah, thanks, Brian. So now we're going back to insurance talk, and I've provided all of these pros of what brokers do for you for free. So why does everyone not use a broker? There's three main things that we've gathered. One is the profit model. You don't know if brokers are scamming you when they recommend you a plan because they are incentivized to sell you the most expensive one. They get paid commission based off of your premiums. So if you're paying more premiums, they're making more money. They also might have special contracts with insurance companies. And yeah, if health insurance is so complex, you have no idea if they're genuinely on your side or if they are just trying to sell you the most expensive one. Secondly, you have to be proactive. Um, you'll have to look through a network of brokers, talk to them, see if they are someone that you want to work with throughout the year, and literally just hop on the phone to partner with a broker. More and more people today who are used to social media, forums, and online don't want to deal with calling brokers. Um, and the third is what we want to get into the most. So it's hard to find a broker that helps individuals. As mentioned, brokers typically serve businesses because that's what makes them the most money. Um, and here's the big problem. Brokers are incentivized to maximize sales and minimize support. What I mean by this is brokers make money if they sell 10 insurance plans and spend all of their time selling people on plans and don't spend their time supporting employees through the year who they sold to. But on the other hand, employees want support. Employees want someone to help them look through all these plans, answer their questions, give them that personalized attention. But that's just not what makes money for brokers. Now we'll talk about ICRA. A lot of concepts. If you guys heard about ICRA, ICRA is something that's really new, came out in 2020, and it's a new way for employers to provide medical benefits. Employers provide, so basically how this works is instead of sponsoring a group plan, employers will give you let's say $1,000 a month, and you as the employee can go to the marketplace and use that $1,000 to buy whatever plan you want. A key point is that employees get flexibility. I'll just name two compelling use cases for you to consider ICRA if that's something you're interested in. Firstly, if you're a remote company, ICRA is a very valid option. Instead of buying a super expensive nationwide plan that covers your employee in New York and your employee in San Francisco, you'll buy ICRA and your employee in New York will buy a New York plan and your employee in SS can buy an SS plan. Saves a lot of money. Second use case I'll mention is if your employees had different needs. Let's say one of your employees is constantly sick or has dependents that need an expensive plan, while your other employees are really healthy and don't need that. Why are you paying for an expensive plan for your whole company when you can just be allowing them to be flexible? Here's a little chart showing how ICRA has grown in popularity. And what's the problem? The problem is in each state marketplace, just the New York City one, there's 105 plans that your employee will have to sift through. Um, the problem is individuals on ICRA plan need brokers to explain to them why would I choose this one out of the 105 options. But the broker model doesn't work for individual health plans because they want to minimize the support that they have to do. What is the market doing? So Take Command and Dash are two industry leaders in ICRA, and what they're doing is literally hiring brokers. So they recognize that employees need advice on what plans to choose, and they solved that by literally allowing brokers to partner with them. We won't get into like two clear reasons why this isn't going to work. Is that it doesn't scale. In order to take on more clients, you're going to have to hire more and more human brokers. And secondly, they're expensive. For a service that we have shown that a computer can do, like brokers, their skill set is much better utilized to like convince people to enroll rather than helping them on these like minute insurance questions. Here's our solution. Part two. So we shown that Demystify AI is able to answer questions that a broker can answer. What we're doing is partnering with Gleam, the company that I work for personally, which is an ICRA marketplace, to use AI agents to solve this problem. So now, for example, in Gleam, you can purchase plans in this way, and we're imagining a world where you can ask Demystify within this app, hey, does this plan cover Ozempic? Is Dr. Doe in the plan network? If I have someone that's sick, is this a good idea? And through this, businesses can get the financial benefits of ICRA while also catering to each employee's need, being a better benefit in general. So yeah, next steps, that is what our plan is after this hackathon. And for a quick recap, one, LLMs, when used in this agentic workflow, are able to use the same document that brokers use to provide the same support that a broker supports. And in this growing ICRA market, there is this unsolved gap created by incentives. And AI agents will help disrupt this market by solving this incentive problem. AI agents can work 24/7 without needing to worry about like what their time is aligned for, with 24/7 instant support. And yeah, thank you. That's our presentation, and here's our contact. Feel free to reach out to me if you're interested in ICRA. And yeah, thanks for hosting us. Hey, Nathan, you there? I think you're muted.
Yeah, we can hear you.
Oh. Hello? Yeah, I think you're still muted.
Yeah. I can hear Darren though.
Yeah.
So much. I'm going to admit Eden and Emily
Yeah, we're good
to
now.
take it away, given my computer issues. But this is awesome. Yeah, I heard everything. Yeah, very cool.
Thank you.
All right, thank you, y'all. Thanks, Darren.
So yeah, I think that is that. I'm gonna essentially hang up this call. But great job, guys. This is incredible. I don't know, Emily, do you want to say anything about DevFest before I go? Or I could just hang up the phone and the stream.
I mean, well, thank you so much for the opportunity. I think it's super cool that we were able to work with you and like do this with the participants and extend the hackathon. Really, I don't know if I don't know if Eden wants to say anything else, but yeah.
Yeah, I agree. It's kind of amazing. So thank you guys, and this was amazing. I'll post the talks hopefully later tonight if I don't run out of adrenaline. So yeah, thank you.